How did ancient coastal sediments preserve such remarkably complete skeletal remains along the famous English Jurassic coast? Why did this 4-meter creature evolve significantly longer hind limbs compared to its much shorter forelimbs? What specific jaw adaptations allowed it to efficiently process tough, low-growing plants instead of taller foliage? How did overlapping bony scutes create a highly flexible defensive shield without completely restricting vital mobility? Could this armored herbivore have survived exclusively during the narrow geological windows spanning roughly 190 million years ago? Which fossil discoveries finally resolved the mysterious evolutionary origins connecting early ankylosaurs to their primitive ancestors? What hidden anatomical secrets within its living stone remains reveal the earliest developmental stages of thyreophoran dinosaurs? Don't miss what comes next in this story. Watch to the very end.
Hello, I am Jonny Dony, and welcome to a channel dedicated to dinosaur documentaries grounded in real science. Today we explore Carved from Earth and Living Stone, tracing the armored Scelidosaurus across ancient coastal floodplains. Platform monetization has grown unpredictable lately, so my work now relies entirely on direct viewer backing. Please consider joining me on Patreon, because every single contribution directly funds the next film, link below. Please like the video and subscribe to the channel to help sustain these careful paleontological explorations. Now, let us step into the ancient past.
Carved from earth and living stone. The earth has music for those who listen. George Santayana. Jurassic Floodplain. The ancient Charmouth Mudstone Formation and the blue lias of the Jurassic coast preserve a remarkably narrow geological window of deep time. 190 million years ago, this early Jurassic landscape was a very warm, low-lying coastal margin. Here, the foundations were laid. A highly stable floodplain ecosystem thrived where regular seasonal rainfall consistently nourished dense patches of primitive cycads and ferns. Beneath the broad fronds, a small synapsid scurries through the damp leaf litter. It navigates a world entirely devoid of flowering plants. Shallow coastal margins and marine-influenced mudstones define this geography, creating a continuous mosaic of terrestrial and aquatic habitats. Overhead, the large shadow of a contemporary pterosaur drifts across the green canopy. It patrols the shifting shorelines for small marine invertebrates. River channels regularly overflow their banks, depositing very fine nutrient-rich sediments across the broad alluvial plains. In the far distance, a contemporary theropod pauses at the water's edge. Its dark silhouette is framed against the mist as it surveys the wet terrain. The dense vegetation consists entirely of ancient lineages, with tall conifer stands and thick tree fern thickets lining the much wetter ground. This highly productive environment sustains diverse invertebrate populations. Early terrestrial reptiles also thrive here, as they navigate the shifting coastal zones. Seasonal floods continually reshape the alluvial topography, burying the low-lying terrain under fresh layers of very fine silt. This relentless geological engine grinds on. It constantly rewrites the vast coastal floodplain across many millions of years of deep, unforgiving geological time. This chapter reveals the Jurassic coast preserved a highly stable early Jurassic floodplain. We want your analysis of how these wetlands sustained ancient reptile populations below. Like and subscribe to follow our ongoing paleontological research. Our next chapter examines how a 4-meter quadruped navigated these exact shifting mudflats.
Robust quadrupedal species. the animal shifts its weight, revealing a remarkably compact body plan built for stability. Reaching 4 meters long, this quadrupedal species distributes its mass evenly across sturdy, pillar-like limbs. The posture remains firmly grounded, favoring deliberate pacing over rapid bursts. Its hind limbs are proportionally longer than the forelimbs, providing enhanced leverage for steady forward movement. This anatomical arrangement allows the heavy torso to navigate uneven coastal terrain efficiently. Every step is measured, anchoring the heavy frame to the shifting mud. Above the dense cycad canopy, a Dorygnathus drifts on thermal currents, its broad shadow dwarfed by the sprawling landscape below. The pterosaur in flight contrasts sharply with the grounded reality of the heavy herbivore. Down here, survival depends entirely on physical mass and stability. Near the massive feet, a small synapsid scurries through the ferns, highlighting the sheer scale of the dinosaur. Despite its bulk, the skull remains relatively small compared to the robust torso. This proportion allows for efficient weight distribution during continuous low cropping activities. Muscle attachments along the back reinforce this structural stability, anchoring the heavy ribs and deep pelvis. The animal pauses, shifting its weight onto the stronger hind limbs to elevate the forequarters slightly. This balanced stance minimizes energy expenditure across the uneven coastal plains. A contemporary Sarcosaurus watches from the distant tree line, but the heavy herbivore simply lowers its head. The robust quadrupedal frame settles back onto all 4 limbs, muscles rippling beneath the skin. It takes another deliberate, measured step forward, an immovable object in a shifting world. How does this heavy herbivore maintain perfect balance across shifting coastal terrain? We traced how reinforced hind limbs anchor its massive frame during every measured step. Like and subscribe to support our ongoing paleontological research. The next chapter reveals how specialized leaf-shaped teeth drive a strict, low-browsing diet.
Specialized herbivore diet. Specialized leaf-shaped dentition and simple biting mechanics define a strict, low-browsing diet. This herbivore crops tough ferns and primitive cycads right at the soil surface, ignoring tall vegetation entirely. Its steady feeding strategy maximizes daily nutrient intake from abundant ground cover plant matter. A contemporary pterosaur glides silently above the river margins, casting a fleeting shadow over the active foraging grounds. Nearby, a small synapsid scurries through the damp undergrowth. The herbivore ignores both, maintaining its solitary territory along the fertile coastal edge. A vulnerable hatchling stays concealed near the muddy riverbank, its lighter osteoderms offering minimal protection against local carnivores. Relying entirely on camouflage, the young offspring waits for the adult to clear the area before emerging to forage on tender shoots. Seasonal rainfall patterns directly dictate the availability of fresh vegetation across the coastal margins. To locate reliable food sources, the solitary browser shifts its foraging territory toward the water edge. Here it crops nutrient-rich algae and soft ferns thriving in damp soil. In the distant tree line, a pure sauropodomorph browses on higher branches, occupying a completely different browsing niche. This spatial separation prevents direct competition for the same plant resources. The browsing herbivore continues its methodical grazing, perfectly adapted to the lowest feeding tier. By continuously cropping the dense ground cover, this specialized herbivore actively shapes the structure of the coastal undergrowth. Its daily foraging clears space for new seedlings to reach the sunlight. This quiet, relentless grazing remains the true engine of the coastal habitat. While earlier chapters detailed our environment and skeletal structure, this segment reveals precise feeding mechanics. We now understand how low browsing actively engineered the coastal ecosystem. Like and subscribe to track our ongoing paleontological research. The next chapter exposes how heavy armor repels sudden carnivore ambushes.
Active predator combat. Two rival Scelidosaurus push against each other across the fern thicket. Rows of scutes and embedded ossicles form a flexible shield that defends the body without fully restricting movement. The larger bull drives his mass forward, forcing the smaller competitor to yield the riverbank. A contemporary Sarcosaurus lunges from the dark cycad shadows in a sudden, calculated ambush. The herbivore pivots, presenting its heavily armored flank to absorb the theropod biting strike. Jaws scrape harmlessly against the rigid osteoderms, and the frustrated predator retreats. A Dorygnathus pterosaur stoops from the high canopy, aiming for the unarmored neck. The quadruped swings its long tail in a violent arc, the heavy tip striking the flyer wings. The giant reptile loses its aerial balance and labors away. Later, a Dracoraptor attempts a coordinated pursuit through the dense horsetail reeds. The armored herbivore halts abruptly, dropping its weight to present a low, braced stance against the theropod attack. The smaller carnivore fails to find a vulnerable gap and breaks off. A second rival contests the victor, feeding territory near the mudstone shoreline. They lock their broad osteoderm shoulders in a grinding clash of muscle and bone. The initial defender holds his ground, pushing the challenger backward into the shallow surf. At the water edge, a contemporary local crocodilomorph snaps its jaws at the trailing foot. The reptile simply shifts its stance, bringing a heavy scute foot down hard on the predator snout. The ambush fails, and the crocodilian slinks back into the estuary. The rising tides will finally drown these armored survivors. We tracked their defensive victories, yet environmental shifts prove far deadlier. Like and subscribe so we can document this extinction. The next chapter reveals exactly how flooding permanently erased their lineage.
Mass extinction. The heavy browsers shift as coastal mudflats gradually submerge beneath a rising tidal surge. Water drowns the familiar green fern thickets. Documented mainly from the late Sinemurian to early Pliensbachian, about 193 to 190 million years ago, this narrow time window marks their terminal decline. High above, a contemporary pterosaur circles the rapidly shrinking shoreline. It searches for stranded marine life along the muddy edge. This severe environmental instability triggers a mass extinction event for the armored browsers, as isolated populations face complete habitat fragmentation without any viable alternatives. Wilebility Prosable Ton. A pure theropod yields the remaining dry ground, recognizing the sheer futility of hunting in the deep floodwaters. This final retreat underscores the absolute dominance of the rising sea. The water permanently seals the fate of the great, ancient coastal basin. Specialized feeding adaptations become increasingly disadvantageous as preferred vegetation vanishes beneath the expanding shallow seas. The heavy browsers wade through the cold and deep saline inundation, Their grounded stance is entirely ill-suited for swimming across the rapidly widening marine channels. Severe environmental instability consistently prevents successful adaptation to the rapidly changing coastal landscape. Isolated groups face immediate and complete habitat fragmentation. This ultimately leads to the permanent disappearance of the entire ancient lineage from the deep and unforgiving geological record. The age of the last early armored giants quietly concludes beneath the endlessly encroaching tides. Their exceptional anatomical legacy remains permanently locked in the mudstone. This serves as a silent testament to a world that ultimately could not sustain them. The rising Jurassic seas permanently erased these specialized low browsers from their coastal habitat. We invite your analysis of this rapid ecological collapse in the comments below. Like and subscribe to support our ongoing documentary research. The next chapter reveals how mineral replacement perfectly preserved their skeletal blueprint.
Stone legacy. A lone Scelidosaurus halts in the shallow estuary, its breathing growing noticeably shallow. The Sinemurian coastal plain offers no refuge for this aging individual. It collapses into the tidal mudflats, its heavy osteoderms sinking deep into the anoxic sediment. Carrion quickly draws a contemporary Sarcosaurus theropod to the muddy shoreline edge. The large carnivore tests the thick dermal scutes with its snout, finding the fallen remains entirely inaccessible. Denied a proper meal, the hungry hunter simply withdraws into the coastal ferns. Rising tides quickly bury the fallen carcass beneath the Charmouth mudstone deposits. Over countless epochs, mineral-rich groundwater replaces the organic tissue, perfectly preserving the articulated skeleton and intact scutes within the dark strata. The physical body vanishes, but its structural blueprint remains. Millennia later, tectonic uplift exposes these mineralized remains along the modern shorelines. Named by Richard Owen in 1861, the recovered specimens provide definitive evidence of early thyreophoran anatomy. Modern paleontology carefully extracts the stone, revealing a truly remarkable and detailed biological archive. Detailed anatomical analysis confirms this taxon as a basal thyreophoran, anchoring the evolutionary tree. The flexible defensive covering demonstrates how early ornithischians combined passive protection with low browsing. This crucial lineage bridges the morphological gap between primitive ancestors and much later giants. Ultimately, these perfectly preserved specimens help resolve the origin of ankylosaurs and the broader early history of thyreophoran dinosaurs. The stone legacy secures a permanent scientific record. This proves the ancient terrestrial browser successfully paved the evolutionary way. Our journey through the Sinemurian coast concludes with this fossilized legacy. We now understand how early armor shaped later dinosaur evolution. Please like and subscribe to support our ongoing paleontological research. Visit our channel library to explore additional deep-time ecosystems.
Our Carved from Earth and Livingstone journey concludes here, and I am Jonny Dony. Thank you for exploring the armored world of Scelidosaurus alongside me through this coastal documentary. Please subscribe and share your favorite discovery in the comments below. Every new dinosaur documentary drops on Patreon a full week before the public release, link below. My deepest gratitude belongs to our dedicated sponsors and channel supporters who fund this research. In just a few seconds, two equally fascinating dinosaur documentaries will appear on your screen. Choose your next prehistoric adventure and continue exploring the ancient world with me today.